binaural banner. It's a user requested thing. So let's create a knob, call it X, create another knob, call it Y. These are going to be the X and the Y coordinates of where the sound source is going to be. Let's create a designer, call it Air. The Air is going to here based on the X and the Y position. So let's create an input for audio and create another input for X and for Y. And the first thing we are going to do is to calculate how distant the X and the Y, how distant the point is, the sound source is. And for that we are going to use the Pythagoras theorem. Multiply X, multiply Y by itself, take it to the square, add them together, and take the square root. Nice. And let's limit the distance for starters on 1 meter. So if the input is smaller than the minimum value that we define, then we output the minimum value or we output the input. Like this. And let's create an input for this minimum so we don't have to come in here and call this clamp. Nice. This is the distance. Plug in X, plug in Y, and create outputs for X and Y like this. And I like to call this underline X. Sorry. And underline Y. Nice, now we can calculate the amplitude. And for that we need the audio input and the distance. And yeah, here the output should be called distance, so you know that you have to plug it here and plug it there. Nice. And simply divide the input volume by the distance. And this is going to be the output. Nice. Now we can calculate the delay that is caused by the distance of the sound source. This will allow us to have the Doppler effect, and this is basically the main part of the binaural effect. And for this we need the distance and multiply it by 0.343 if I remember well. And that's done. And here I need to bypass the distance so I can patch nicer. Like this. And we need to calculate the angle. So we can take the head into consideration, which blocks out frequencies and also the volume is affected by it. For this we need the X and the Y. Let me copy this input plex and create a node called A10, because we are going to use the ArcTangent for this calculation, which gives us the angle of where the sound source is, but it's always going to give us the smallest angle. Like yeah, I will probably do a graph of it. So we will do 1 divided by X and take the ArcTangent of this and multiply it by 4, because the ArcTangent is a bit modified in Alpha Forever, but this gives a nice result. And if this is if X is about 1 or 0, excuse me, then we will output 1 as we will output the result here. And let's use the epsilon of, let's say, a small value. And this is the output. called Ableton, like this. And now we can patch in X and Y, and we will again bypass X and Y. I always forget to bypass, but anyways, underline X, output. It's not a mandatory, but this way the patch looks a lot cleaner. And now we can calculate the direction by checking for several cases. So we need the Ableton input and X and Y, and they are okay in order. And if X is smaller than 0, then we add 2 to the Ableton. Like this. And then we check for Y. If Y is smaller than 0, then we add 4 to the Ableton. If none of this is happening, then we output Ableton. And this is the direction. This gives a value between 0 and 4. So we multiply it by 90, and then we get 0 and 360 degrees. Let's patch this and output the direction. Done. And we can create a custom function from 0 and 360 degrees. I like to use it like this in this case, and turn on snipping and create a crossfader. And the Y of the custom function is going to drive the crossfader, and the input on 0 is going to be the delay, and the input on 1 is going to be the delay, but filtered. And yeah, this is going to be the output. So this is what we are going to hear with our ear. And yeah, let's bypass some values here, like the input to the right ear, the X, the Y, and also, what else? Yeah, we will need a size here, so to know what size our head is. So let's create an input for size, bypass the size, and also create dampening and output the dampening. And actually, this is one ear. This is what we are going to use. So let's call this ear left, and this one ear right. And create a stereo track. These are the inputs and outputs. And one more thing that is a nice addition is to scale the X and the Y using a gain line. And create a variable for the maximum size like this. And output 1, output 2 are going to be underline X and underline Y like this. X comes here, Y goes there, like this here. Create a knob for the maximum value, and yeah, X should be in between -1 and 1, Y should be in between -1 and 1, which represent 1 meter to the right or to the left, or in front of us or behind us. By setting the maximum value between 1 and 40, then we define that we multiply this distance. So if we move this to 40, then X will represent a value between +40 and -40 and so on. So let's move this to 10. And let's create this as a VST parameter for 1 and 2. And here I had this before on X and Y, that's why they show up, but this way we can control the parameters like that. And let's bypass everything here, like 5 values, and there. Okay, let's create an input. And we will read only one channel because we need a mono source. And the volume here, will, the signal that comes in here will represent the signal at 1 meter distance. And also create a knob for the head size. I will set it to 0.2-ish in radius. And on this input, let me use the inverse of the size. And yeah, one thing that we need is to create this crossfader curve. So this is the left ear. Let's go over all the possibilities. So this is the left ear. What if the signal is in front of us? That's okay. Let's go down. This is on the left ear, then we won't alter the signal. This is a bit behind us, so we filter a bit. This is completely behind us, so we go completely behind us. That's on the opposite side of the head. That's fully filtered, of course. So the start and the end points are also completely filtered. This is in front of us, so a bit of filtering should happen, but we should hear it. And this is in the center. So this is the curve that we are going to use for the left ear. And for the right ear, we are going to do the same again. Like we start from the front and go to the left. This is a bit filtered. This is completely filtered. Completely filtered. Completely filtered. And this is just a bit filtered. And we are done because that's fully okay, fully okay, fully okay. So then this is a binaural banner. And let's try it out. Let's move everything to the center. And one more thing, before I forget, that it's convenient if we have this minimum here, like this, and like this here. And for the time being, this is on 1. It's good that I did not forget about this. So now we can go closer than 1 meter for the starting, for the first time, but then we will allow it. Okay, I have a drum track prepared. It would sound nicer with a car or Syrian sun, but let's see if this is going to work. I play it. Let's move to the right. To the left. 10 meters. To the front. Okay, looks like it's working. Now it's behind us, in front of us. Okay, let's move this to 1 meter. Oh, this is 10 meters. Okay, to 0.1 then. So this is 1 meter. Let's turn the minimum to something lower, like 0.3. Now we can come closer. And if we set the distance to something higher, then we can hear the Doppler effect kicking in. Can we? Yeah, we can. I just forgot to turn up the maximum. Yeah. What if I put a reverb here? Okay, that's it for today. I hope you had fun. Bye bye.